I'm not very sure it's actually the way this node needs to be handled, but yeah, for some reason I just everyone that is good at compositing throw me tomatoes at this point. But yeah, we build a freaking Ray Marcher and Nuke.
Yeah, real Snoopy shit. Cody, what it does?
Well, hello, and welcome to this new tutorial where we are going to take a look at Blink node in this wonderful software you're seeing here called Nuke. Nuke is made by the Foundry, and it's pretty much the go-to for compositing nowadays in the field of cinema and movies, TV shows. Just before starting, I want to say I'm very far from being a compositor myself. I kind of have fun playing around with this software, but it's far from being my field of like what I do on a daily basis and stuff. But I talked with some friends this weekend. We were in the countryside and on the boat. We were riding on the lake, whatever. And it was like we were discussing about Nuke, and my friend that works as a compositor in a big studio, he told me, well, you should take a look at Blink, because people do some incredible stuff with that. I hope this is you watching, that you're doing some crazy stuff with Nuke. But today is not about creating crazy stuff with this node, but simply going through how it actually works in Nuke and how we can start to explore a little bit the different ways to create image, and I guess that at the end of this video you're probably going to have a much better understanding about how this node works in Nuke, but also how you can use it to, I don't know, create whatever tools could be necessary in a compositing pipeline or compositing project. But as mentioned, it's going to be like more computer programming approach than compositing approach. The reason why, as I mentioned, I'm not a compositor and I'm deeply bad at it, but I just like the idea of Blink, and we're going to go and explain a little bit how everything's work and how we can manipulate pixels and stuff. So if it's something that interests you, let's dive in. So the first thing we will want to do is to create a new Blink node, Blink script node, and I'm just going to shoot it into my viewer, and we're going to have an error. The reason why, for some reason, we need to put a texture. So I'll go with the classic checkerboard, and then everything we're going to work with in this node is in the kernel source. We will basically delete all of these and start by writing our own kernel from scratch. This way we have a better understanding of what's happening.
Juicy J with that. Yeah, it's good.
So before starting talking about Blink kernel and source code, I think it's important for us to describe a little bit what is Blink. And from this page, it's a framework which allows you to write code once and run it through all your supported device. So basically what it says, it's like you take some code that is similar to C++, to a C++ class, and you write some code that will output a texture or an image, and you can shoot into this node some data. Could be textures, could be videos, could be floating points, hint, anything you want. Your creativity is the only limit. I won't cover how everything is actually like built and like all the syntax and all of these, because I want this to be a very short video. So I guess that from this point, if you understand that this is, if you take a look at this graph, it's like we have a checkerboard, we have a blink node, and then we shoot it to the viewer, and we're going to start messing around in the kernel source code, where we're going to make some, well, image and manipulate pixels. So to work with these kind of kernel, you could either load a kernel file or type in the source code. Because we're going to go with very simple example, I will type straight pipe into this one here. But if you go onto this browser file here, you can select any type of well, text file or like your source for the kernel you want to write. But for now, let's just dive into this one by typing it in here.
Juicy J with that. Yeah, it's good. Uptown song.
My simple kernel.cpp. The reason why I put CPP is that the syntax highlighting works a lot. Like the Blink script is not C++. It's like a mix from HLSL, which is the DirectX shading language, and and C++. But yeah, so I don't want to like zoom in, so I'm just going to put it here, and we're going to type our code in here. So the first thing we will want to put in is the kernel, and then the name of our kernel. So I'm gonna say basic stuff, and this guy is going to heritate from the image computation kernel, and we pass it pixel y. Right? So at this point we need to define two things. The first one is an image e-read, and pass it the also e-axis point. Right, I'm typing all of it, but honestly, like as mentioned, we won't very cover how everything of those work. So let's just copy paste this one and say that not e-write, and this is going to be the destination. Then we're going to say parameter local, and we need three like we need three functions. The first one is a function that is called define. I'm gonna leave it empty for now. The other one is a function called init, and the other one is where we are going to write the meat and potatoes of our program by calling it process. So I think we need to take like all of these stuff. We're going to make video later that will explain how it actually works. But if you are like somehow you already work with image and C++ and stuff, should not be like, or even like super basic like JavaScript like P5GS or Canvas. It's not super different, where it's like you're in it, it runs once when we start to run the code, and the process, well, it's where everything is gonna work. So everything is going to be processed. So let's assume like you have a texture that goes from 0 to white, or like black to white, and you would like to assign this this, like not this texture, but like this video of like a video going from black to white, and you would like to assign this video through the output of this Blink node. You would simply say that the destination is equal to the source, and we define the source here, and the source is what we send basically the data into this node. In our case, there is a checkerboard texture, and image eWrite DST for destination means that we, oh, and I think I typed it wrong. It's not, it's DST, not dist. And this means that it's the output value of this node. So in our case, if we take, and this is the most boring, if we click recompile, oh yeah, I mean, okay, the debugger is quite nice, honestly. It says, oh, use of undeclared data for pixel-wise. Did you mean X? Pixel-wise? Yes, I meant that. Thank you, Nuke. Now it should work. So now, well, we have the, it's super basic. We have basic source, which is this texture, and then we pass the destination, which is the output from according to what is that source, which is this texture. So it's basically just taking the checkerboard and assigning it to every pixel in the process, and then we shoot to the viewer.
Juicy J with that. Yeah, it's good. Up top.
Cool. So now that we have seen all of what we want to work with, let's change a little bit how we deal with the source and the destination to make Nuke able, or make the Blink script able to access and modify every pixel. So we want to define the coordinate of a certain pixels and then change its color. So the first thing we need to change is to, I'm just going to reopen Nuke, is to change that to e-axis random, and also make the destination e-axis random. As mentioned, all of these weird brackets and sign, don't worry if you don't really understand what's going under the hood. This video is not about to understand the inner core of that, but just to bring you the basic boilerplate for you to use. If you want to go deeper, like the Nuke documentation is just very, very well written, and everything is described here. So before diving into basic pixel manipulation, I want to take, if you are a programmer, you can skip this part because it's going to be boring, but if you are like a compositor or a 3D artist, we need to talk a little bit about variables and types. Computers deals with memory, and your memory, like computers even simpler, they deal with data. Your CPU has a bunch of instruction and pointers and it's just crunching numbers. That's what your computer does. So we need to find a way to talk with a computer using like our human language, which is like how we deal with numbers. So if I say, how old are you? Like I'm gonna say I'm 25, right? So I could say my age is equal to 25, and what I mean by int is it's an integer. It's like a whole number, 1 2 3 4 5 6 7 8 9 10, whatever, like -1 -2 -3. Then if I ask someone what is how many money you have in your pocket, right? So if you have $1.25, there's no way you can say int my money, right? It's gonna be, oh, I have $1? No, I have $1.25. So we cannot store that like decimal number into this type. So you have the type, the name of the variable, and the value. So for money, like which is decimal, we need to go float, which is floating points, which is just a fancy names to say decimal number. Like it goes we could go deeper, but let's keep it short and sweet. So my money is equal to 1.25, I said. So that's it. So those are the two types. In C++, you don't have float 4, float 3, float 2, but in kernel and in Blink script, you have all of them. You have float 3, you're gonna see them pop all around, and it's float 3, float 2, float 4. The reason why we have float 4 is because, like, let's assume I want to describe the red color. Like, from an artist state of mind, what is the red color in an RGBA fashion? Like, you're gonna say, well, my red channel is gonna be to 1, my G channel is gonna be, my green is gonna be to 0, my blue to 0, and my alpha to 1, for the sake of this exercise. But how not convenient is that to say, okay, well, is there a way I could just say, well, pack all of these 4 values into a simple variable? Like, I want to use red. Like, I don't really care about, like, I know my red is 1 on the red, like RGBA, and I know there's going to be 1 on red, 0 on G, 0 on blue, and 1 on alpha. Like, why would I need to go and define all of these like red color R, right? Red color, red channel. Then you could say, oh, cool, my value here is 1. Then I could just copy paste and say red color, green channel, right? And say it's 0 and blah blah blah. We don't want to do this. So the good thing is Blink allows us to use float 4, which is just like a wrapper. Just like my age is a whole number, 1, 2, 3, 4, 5, 6, 7. My money is like a floating point decimal number, 1.25, 2.53, whatever. Float 4 is a type that contains 4 components: X, Y, Z. Is it W? I'm not sure, sorry. Like, it contains like 4 components, and what we say is like, well, if you are dealing with red, we know that red is RGBA, so we could wrap all of these values into the same type. Don't know if it makes sense out of this, but maybe have like a little fun, write some new color. So like float blue, float 4, if it's blue. So we could go float 4, and this is called the constructor. As I mentioned, I don't want to really go into how the programming works. Just explain the core concept or basic concept anyway. So blue is gonna have 0 on the hex, 1. No, sorry, Sorry, English is not my first language, so sometimes I need to spit that in French. And then 1 on the alpha, so that's gonna be blue. You can define new colors. And right, next step, let's dive into writing some pixels. Alright, so our next step is going to write pixels at certain coordinates of the image. So to access these, what we've done is we manipulated the source and the dist by passing e-axis random and e-axis random to both, which allows us to access certain pixels of the texture we want to manipulate as an output. For now, it's going to be 0, 0, and I'm going to assign the red color to this pixels, and Nuke start to count at 0, 0, 0, 0 is left bottom, and 1, 1, or like if we go from, because we're going to dive into UV after, but it's like if we were to, I'm just going to open the snipping tools. I think it's going to make a bit of more sense. If we were to start, So if we were to start plotting the U or the X and Y of the pixels, that would be X, oh my god, sorry, X, and I'm going to put the, oh, I'm so bad at drawing, so X and Y, X, that would be like 0, 0, and 1 on, if we were to write between 0 and 1. But we don't really, we're going to deal with those type of 0 and 1 later when we were going to compute the UV, but for now, let's just assume that we want to access every pixels based on the position of like basically the pixel number, as you see in here, X, Y, and stuff. So 0, 0 is there. So if I reopen back my script and say I'm just going to remove stuff we made, like we're going to see, well, we have red. So guess what? The very sad, lonely pixel at 0, 0 is going to be red. I'm just going to shoot that. Oh, we have an error. I meant forgot to put the semicolon. And now, well, we don't see it because we need to zoom, but if I zoom 0, 0, here we have our first pixel. How not very exciting it is, but still we have a tool, a very powerful tool in here, meaning that we can write using extremely parallelization, like highly parallel computing from the GPU to create image and to create effects and to process whatever comes in, or to create whatever comes out, or to combine both together. So I know it's been a super long video just to show one pixel, but let's change the color of that pixel, and then maybe we're going to draw a line after. So now it's gonna be blue, and so on. So yeah, here it is, the how to write a simple pixels in the most not direct way using Blink node. Next we're going to start to take a look on how to draw a line, and after we're going to expand to 3D to create, I want to say fractals, but let's start by making a simple sphere and stuff. But for now, all this code is available on the GitHub, so just go onto the link and follow. Every step is there. So if anything you missed, anything that is not clear, anything you would want me to go deeper, if you have question, comment on the YouTube section. To be honest with you, I check every comment and I answer them, and if you have question, just I'll give you my email and stuff. So okay, next step, draw some lines.